participants. My name is Yuri Skorenki, and it is my pleasure to present to you in this short talk and the approach and some preliminary results of development of digital twin interface undertaken by two teams in Ternopil Ivan Piliui National Technical University. It is well known that digital twins represent the current stage in development of automated and data intensive smart manufacturing enterprises, and in such an enterprise not just material flows are processed but also lots of data both coming from external stakeholders and produced during the cycle, during the life cycle. So both those data and material flows are to be taken into account when building models for such processing. And as a pilot, one of metal processing floors in civil engineering company was taken, which was equipped with automated welding machine, and that was the central part of production of metal parts. Except of that central parts, there were also other stages of the life cycle which are short-named as phases here. Mostly those phases are accompanied not only by the processing of raw materials and metal parts, but also by taking some measurements, both for sake of quality control and also for optimizing the production, for serving better to the customer needs, for making the production more flexible and tunable. In particular, except of this phase 0.3, which is obviously welding, we have lots of micro-logistics phases here, during which different kind of measurements can be done. And after correcting press, we have some additional heating which consumes energy, so different kind of energy power consumption measurements are to be in place to make this production compliant with sustainability goals and more effective. And we also have painting, and we also have laser imprinting. So each of multiple phases present in the processing can produce not just metal parts but also data necessary for optimization. Therefore, those data must be carefully considered and classified in order to separate the critical data, the critical information, and fit that information into the model, but importantly represent those data, represent those signals, informational signals, in human-friendly form, for which purpose augmented reality serves the best. So in this research we developed another instance of augmented reality application, and the interface of augmented reality proves to be importantly uniquely useful and convenient for representing critical information. We have developed and implemented an approach to construct such an image, to design the augmented reality and augmented reality visualization, which will allow workers to take decisions in real time. And data here come from different kind of object trackers, IoT devices, process controls, external and internal data stores. So this is really a data intensive smart manufacturing, which is characteristic for Industry 4.0. So the first step here is, of course, creating a realistic visual representations, 3D models, which then are superimposed onto real objects. And here you see the prototype. This is how the prototype looks like. In this prototype we have the superimposed data here with explanation, which appear in due moment in due place. So as a conclusion, I should stress that in informational technology, augmented reality enabled digital twins are the next step for development. Thank you for your attention.